All right, so looking on slide 15 right now. Again, you just put this in the pink box. These are the instructions. So when we work today on adding and subtracting, the first thing we're going to do is get a common denominator. And that, most of the time, we have to do that. This very first example, we're going to see it's already done for us. And then after there's a common denominator, we will either add or subtract the numerators, depending on if it's a plus or a minus in between the two fractions. And then last, your final answer will be whatever you got when you added and subtracted over whatever your common denominator was. So again, your answer is going to look like a fraction. So go ahead. We've got just a few examples to look through today. We're going to write this first example down and start working on them. All right, so you will always check your denominators first. And like I said, most of the time, these denominators are going to be different, and we will have to get a common denominator before we can do anything else. Sometimes they give you an easy problem where the denominator is already the same. But you want to check that first because you do have to have a common denominator before you can move on and actually add or subtract. All right, so for this one, already have a common denominator. So we're ready to move to step 2, which is just figure out what the symbol in between is, right? This one's plus. So all we're going to be doing is combining the numerators. 3x plus 3 plus 4x minus 2. Okay, so and when we do that, we would get 7x, and then 3 plus a negative 2 is plus 1. All right, so we're just combining our like terms on the top. And then our final answer, again, it has the common denominator on the bottom. So 3x plus 2 stays as our denominator. Sometimes people will do the whole problem and they'll add or subtract the numerators, whatever they're supposed to do, and they forget that when they're adding or subtracting fractions, the denominator stays the same. So you don't add these together. That's why we get a common denominator first, and then that common denominator is going to be the denominator of your answer. Okay. So again, really basic example for the first one because the denominators were already the same. So we'll move on to slide 16 and we'll look at a couple more where we have to get our own common denominator. So I'm going to write down a couple of the problems from slide 16. Okay, let's look first at 9 over x minus 3 over 8x. Okay, we're going to look at that first problem from slide 17. So we always want to check our denominators first. So we have x and 8x. So they are not the same right now. So we are not able to add and subtract fractions until the denominators are exactly the same. So when you see that they're different, what you want to look for is what do they have in common already. So this time I see that they both have an x. Okay, they both have an x. This one has an 8 and this one is just 1x. I can't change 8x to just be 1x. Like that's not possible. But I can change x to be 8x so they can be the same. So you're kind of looking at two different things when you're trying to find your common denominator. You might remember calling it like your least common denominator or your LCD when you learned how to add or subtract fractions. The first thing you'd want to look at are the actual numbers. So like 1 and 8. Well, the smallest thing that I can, the smallest multiple of 1 and 8 is going to be 8. Okay. Now again, they both have an x this time, so I need an x in the denominator. Even if only one of them had an x, we would need an x in the denominator. And we're going to see that. We have a few different examples to look through and see, you know, what different things can happen. But basically, you want to pick your denominator that you can only multiply to change this one. And you want, if you can, you try to make like 1x, you try to just make it 8x. We'll see that doesn't always happen. Sometimes you have to change both of them. And remember, when we're changing our denominator, we're multiplying the top and the bottom by whatever we need to get to 8x. So if I need to multiply 1x by 8, I can't just multiply the bottom by 8. I have to multiply the top and the bottom, because then I'm really multiplying by 8 divided by 8. I'm really multiplying by 1. I'm not changing the value. Okay, I'm just getting a fraction that's equivalent but has the same denominator. So when I do that, I actually have to multiply 9 times 8 is 72. 1x times 8 is 8x. And this time I don't have to change the second fraction because it already has 8x. So I'm just going to bring it down. I'm going to bring down the minus. I'm going to bring down the 3 over 8x. Okay. So that was the extra step of making sure that now we have common denominators. They are the same. So what we're able to do now, this time we're subtracting because there's a minus in between them. So we're doing 72 minus 3. 72 minus 3 is 69. That's the numerator. And then remember, your denominator stays 8x. Get a common denominator and then it stays the same in the final answer. So 69 divided by 8x would be your final answer for this one. Okay. So if possible, try to just change one of the fractions denominators. It's not always going to be possible, but we try to do the least amount of work in these. Okay. Let's look at the one that was below that, which was 3x over 4 plus x over 7. So this is still on slide 16 on the left, but it's the one on the bottom. Okay. And after you write it down, you look at your denominators, and I cannot keep 7 as my denominator. Can't keep 4 as my denominator either, because I can't multiply 7 by anything and get 4. Can't multiply 4 by anything and get to 7. So this is where we want to start thinking that we're trying to find our least common denominator. You might have heard before, like you're trying to find the least common multiple. So a number that 4 and 7 both divide into, right? So for example, 12 wouldn't work. Even though 4 divides into 12, 7 doesn't, right? I can't do 12 divided by 7. All right, so sometimes, the numbers are usually pretty small, right? Got a couple of you already tell me, you already see it. Awesome. So 28 would be the smallest one. So that's what I want to go for. Okay. And then just a reminder here, a lot of this is review of fraction skills, right? Whatever I need to multiply 4 by to get to 28, I just need to multiply the top and the bottom. So I need to multiply 4 by 7. So I'm going to multiply the top and the bottom by 7. And that's going to make this fraction have a denominator of 28. Over here, the second fraction, I need to multiply 7 by 4 to make the denominator 28. So that means I also have to multiply the top, right? So let's do that. This fraction would become 21x on the top over 28, which is good. We were trying to get 28 as our denominator. Bring down the plus. X times 4 is 4x, and then again, 7 times 4 is 28. So we got a common denominator, right? That's the hardest part, is getting the common denominator. After that, you're just adding or subtracting, okay? And then just make sure you pay attention. This one's adding, right? So 21x plus 4x is 25x, and then bring your denominator over. So 25x over 28. Okay. All right, before I tell you this time, I'll give you a second, write it down, and then think what your least common denominator is going to be. All right, so when I look at them, I see that they both have a 4. That's good. So there's a 4 that's going to be in my denominator. This one has an x, and this one has an x squared. I can't make x squared drop down to x. Like there's nothing I can multiply by that's going to make this x squared go away. So my only option is to make them both have an x squared. All right. How can I, tell me in the chat if you know, how can I get 4x to become 4x squared? What do I need to multiply by? All right, so 4 times x squared is just 4 times x times x. Over here, I only have 4 times x. Maybe that helps you see. What would I need to multiply by? Good, good, good. I'm getting a couple answers now. I need to multiply by 1 more x, right? Because I have x squared here, which is 2 of them. I only have 1 x here. So I need to multiply the top and the bottom of the first fraction by x. Now what that does is it makes this exactly the same as the second fraction. 4 times x times x, 4 times x times x makes it 4x squared, right? It does introduce an x on the top that we didn't have, but that's okay. Because remember, our focus is to get the denominators to be the same. So now we've got 7x over 4x squared plus this fraction didn't change. It stays the same. All right, that second fraction didn't have to change any. And when you go to add these, I can't combine 7x and 5. So my answer just has 7x plus 5. They're not like terms. I can't make it 12. I can't make it 12x. So I just leave it as 7x plus 5. And then I bring my common denominator over. So 7x plus 5 over 4x squared. That's your final answer. All right, so we found our common denominator, 40x. We multiplied top and bottom by what we need to get the denominators to 40x. So that makes this fraction be 5 over 40x. Bring down the minus, 72 over 40x. Now we have common denominators. So our denominator of our answer will also be 40x. And you're just subtracting 5 minus 72, which is negative 67.